Assalamualaikum. Right, in this video we're gonna look at limit to infinity, in which if we have like for example this is the a graph like this, right? So we have the infinity where it is positive infinity and negative infinity, and we could see from these graphs if we go at x-axis as x approaches infinity, meaning that if we go to the rightmost of the graph, and then we could see that in this case the graph will approach as x approaching positive infinity. So this approach the positive infinity, it means that the graph goes upwards, all right, and it's never ending there and never touch any point there, but it's like approaching to positive infinity, is going upwards. So in this case we can say that as x approaching positive infinity, so in this case the y will approach positive infinity, right? What if we look at as x approaches negative infinity? All right, so as x approaching negative infinity, so it means you go to this side, the leftmost, so we could see that this graph will go downwards, so meaning that it will go downward, down, never ending, right? So that means it's going towards negative infinity. So in this case, as x approaching negative infinity, so the y will approach negative infinity. Okay, so that's the idea of what infinity is and what limit approaching infinity. Right, let's see this one. As x approaching positive infinity, meaning that if we go to the rightmost of the graph, all right, rightmost of the graph, as x approaching positive infinity, all right, go to the right means this graph will go downwards, means it's approaching negative infinity. All right, so y will approach negative infinity. So in this case, all right, as x approaching positive infinity, so y will approach negative infinity. But what about as x is approaching negative infinity? If you go to the leftmost of the graph, so it will go also to negative infinity, go downwards. So it means that as x approaching negative infinity, so the graph will approach negative infinity also. All right, okay, so the next one, all right, so for this case, let's say we want to see as x approaching positive infinity, so you look at the graph, so this graph will approach the value, right? It is actually approaching this line, all right, where this line is represented by the value 3. So as x approaching a positive infinity, so y will approach the number 3, will approach, it's going nearby the number 3, but it's never touching that number, right, in this case. All right, so it's like this is your crush and this is you never touch it, you never meet each other, or something like that. Right, you just meet but you never talk to each other, something like that, right? Okay, so that's the idea. This is approaching the number 3, so while we approach positive 3, but in this case, as it's approaching negative infinity, this graph will approach to and not any number, but it will go to the negative infinity. So as it's approaching negative infinity, so y will approach negative infinity, right? So this is limit. For example, if we want to say let's say this is the function fx, all right, so what is the limit as x approaching positive infinity of fx? So in this case, the value will approach positive 3, so the answer will positive 3. All right, so this is the idea of what limit to infinity is. All right, so to do this, we have to note that if we have like kind of 1 over 0, right, when we have 1 over 0, so 1 over 0 is actually approaching infinity. All right, 1 over 0 is approaching infinity. Okay, and 1 over infinity will approach 0, right? Later on in your calculation, if you have if you meet this, 1 over 0 will be infinity, but if 1 over infinity would be 0. And we know that we have one tip here, all right, that we have, all right, to divide the highest to divide each term inside your expression with the highest power. It must be the highest power of x in the denominator, right? What does it mean? All right, let's look at question number 1. Okay, we have this type of function. If we try to substitute with value infinity inside x, so we'll get infinity over infinity in this case, which is of course leading to infinity. But actually we can solve this by dividing each term but with the highest power of x that occurs in the denominator. Alright, so firstly we have to identify which is the highest power of x in the denominator. Right? This is the denominator. So which one is the highest power? So this is x to the power of 4. So we have to divide with x to the power of 4 for each term. Alright, so for each term. Alright, so in this case, right, so limit as x approaching positive infinity. In this case, positive infinity is not written. It's positive is not written there, but it means positive infinity. X to the power of 4 divide with x to the power of 4. Alright, plus 2x to the power of 2 divide with x to the power of 4. We divide every term with the highest power of x that occurs in the denominator. So 7x divide with x to the power of 4. Alright, so we'll divide the whole thing with 3x to the power of 4 divide with x to the power of 4 plus x to the power of 3 divide with x to the power of 4. Means each term is divided with the highest power of x in the denominator. Alright, so now we'll have to simplify it first. So limit as x approaching positive infinity. Right, x to the power of 4 divide with x to the power of 4 will get 1. Alright, so next one, 2x squared divided by x to the power of 4, so we'll get 2 over x square. Simplify. Alright, so the last one will have 7 over x to the power of 3. Right, the whole thing will be divided with 3x to the power of 4 divided with x to the power of 4 will get 3 plus x to the power of 3 divided by x to the power of 4 will get 1 over x. Alright, now the part where we have to substitute the value of x with infinity. Alright, but you know, it's kind of when x approaching infinity, so the whole thing here will become 0 because 2 divided by infinity will get 0. This one divided by infinity will get 0. 1 over infinity will get 0, so leaving only 1 over 3. Alright, kind of like that. Right, so never mind, we'll just write something like, alright, if we have a limit, sorry, I'm substituting the value of x with infinity now. Alright, so we have 1 plus 2 over infinity plus 7 over infinity, the whole thing 3 plus 1 over infinity. And we know that the whole thing that divides the infinity will go to 0, so this part will go to 0, 0 and also 0, so we'll have 1 plus 0 over 3 plus 0, so your final answer will be 1 over 3. Okay, so instead of 3 infinity over infinity case, in this case we can actually get a value of 1 over 3, meaning that for this type of function, alright, if we have this function, so when we try to look at the function, so the value will approach that 1 over 3 actually. Okay, as x approaching infinity. Right, what if as x approaching negative infinity? Alright, we have to use the same rule where we have to divide with the highest power of x that occurs in the denominator. So focus at the denominator. So which one is the highest power? So of course the x to the power of 3 is the highest power. So every term should be divided with x to the power of 3 in this case. Alright, so limit as x approaching negative infinity has no effect at all. You just write it that. Alright, so 7 divide with x to the power of 3 plus 2x to the power of 3 divided by x to the power of 3. Divided, right, x divided with x to the power of 3 minus 2x squared over x to the power of 3 minus 4x to the power of 3 over x to the power of 3. Right, so now we have something like this. We have to simplify first. You simplify each term. All right, so you got 7 over x to the power of 3 plus 2, the whole thing divided with 1 over x squared minus 2 over x minus 4. Alright, so please take note that later on we're going to substitute every term with negative infinity. Right, so we'll have kind of, alright, 7 over negative infinity plus 2, alright, So 1 over negative infinity square will get positive infinity, minus 2 over negative infinity, minus 4. But never mind, the whole thing that has this infinity will go to 0, right? So we'll have 0 plus 2 over 0 minus, never mind, 0 minus 0, 0 plus 0, minus 4. So in this case, we will have 2 over negative 4. So this should be simplified as negative 1 over 2. Okay, so for this case, right, so we'll have the final answer as negative 1 over 2, meaning that the graph will approach negative 1 over 2 as it's approaching negative infinity. Right, so let's move on to number 3. Right, in this case, please look at your denominator, and the highest power is actually x to the power of 4. Alright, so please note that this is the highest power, where x to the power of 4. So we should divide every term with x to the power of 4. Alright, so we'll have limit as x approaching a positive infinity. Alright, 3x squared divided by x to the power of 4 plus x over x to the power of 4. The whole thing divided by x to the power of 4. Alright, x to the power of 4 minus 2 x squared divided by x to the power of 4. Okay, so now we're going to simplify this. All right, we'll have limit as x approaching a positive infinity of 3 over x squared plus 1 over x cubed, the whole thing over 1 minus 2 over x to the power of 2. Okay, so we're going to substitute x with infinity. We'll have something like 3 over infinity plus 1 over infinity, 1 minus 2 over infinity, something like this. So the whole thing that has divided with infinity will be 0, right? This one goes to 0. So we'll have, all right, so I'm writing in the next line. We have it as 0 plus 0 over 1 minus 0. So this is actually 0 over 1. So the final answer should be 0. Alright. So please note that your final answer in this case is 0, meaning that the graph will approach to 0 as it's approaching positive infinity. Alright, let's move on to number 4. Right, please take note that the highest power of x in the denominator is actually x to the power of 1. So we are going to highlight this one first. All right, so we're going to divide every term with x to the power of 1. All right, so approaching negative infinity. So you divide, all right, each term with x minus 1 over x, x over x plus 1 over x. All right, so now we're going to have, all right, 4x minus 1 over x, 1 plus 1 over x. All right, now we're going to substitute. All right, I'm not, all right, I was leaving this limit as x approaching negative infinity because we have not substituted the value of x with negative infinity yet. So 4x minus 1 over x. So this is 1 plus 1 over x. Alright, so now we're going to substitute the value of x with negative infinity. We'll have something like, alright, 4 multiplied by negative infinity. Right, so minus 1 over negative infinity. So we'll have 1 plus 1 over negative infinity. So this will actually leads to, alright, so 4 multiplied by negative infinity. Negative infinity is kind of a very big number. 4 multiplied by that big number will become bigger, right? So it means that it will become more negative. So it will become negative, not negative 4, negative infinity, right? Like for example, you multiply 4 by million, so negative million. So you get negative 4 million, right? So in this case, you don't have to write negative 4 infinity because infinity already represents a big number, right? So this one will get 0 over 1 minus 0, right? So in this case, actually negative infinity divided by 1, so you get negative infinity, right? Meaning that as it's approaching a negative infinity, this graph will lead to negative infinity, right? Will approach to negative infinity. Okay. Please note that negative infinity divided by 1, we get to negative infinity, not that 1, all right? Because that big number will what we call that will be the dominant here. All right, now we're gonna have this one. All right, so the same goes here. We have this is the highest power of x in the denominator, so we'll have limit as x approaching negative infinity. All right, we divide everything with x, so 5x to the power of 3 divided by x plus x divided by x, the whole thing over 2x divided by x minus 7 divided by x. Alright, so simplifying that, we'll get the limit as x approaching negative infinity. So we'll have 5x squared plus 1 over 2 minus 7 over x. Now what we're gonna do is that we have to try to substitute the value of x to negative infinity. So we'll have something like 4 multiplied by negative infinity square plus 1 over 2 minus 7 over negative infinity. All right, so we are trying to substitute this. So means if you get negative infinity square, negative number, or if you square it, it will become positive. So this is actually lead to a positive infinity. All right, so your final answer will get positive infinity, right? Meaning that we just have to calculate this part because this is the dominant here. That's the biggest number. What we call that, positive infinity divided by 2 or whatever number will still remains as positive infinity. All right. So in this case, we'll give you to negative positive infinity. All right, because we have the square here. Okay. All right. Alright, so let's move to number 6, alright, where we have this square root, alright. Don't be afraid of that square root. You just have to do the same thing here, where you have to divide with the highest power of x that occurs in the denominator. In this case, you have x to the power of 4, you have x to the power of 4 and x to the power of 2. Which one is the biggest? Of course, this is the highest power of x that occurs in the denominator. So in this case, but please don't forget the square root symbol. Right, limit as x approaching a positive infinity. Right, in this case, right, so we divide everything with x to the power of 4. Okay, plus 7x squared divided by x to the power of 4 minus 5 divided by x to the power of 4 over x to the power of 4 divided by x to the power of 4 plus 2x squared divided by x to the power of 4. But don't forget this square root symbol, right? So now you're gonna simplify that, all right? Limit as x approaching a positive infinity. So you'll have 16x to the power of 4 divided by x to the power of 4. You got 16 plus 7 over x squared minus 5 over x to the power of 4. The whole thing over 1 plus 2 over x squared. Alright, so next is that we're going to substitute the value of x with positive infinity in this case, but don't forget the square root symbol. So 16 plus 7 over infinity minus 5 over infinity. Alright, 1 plus 2 over infinity. So now you will have something like square root 16 plus 0 minus 0 over 1 plus 0. So this should be simplified as square root 16 over 1. Square root 16 over 1, this is actually square root 16. What is square root 16? The final answer should be 4. Okay. So your final answer will be 4. Alright. So let's move to number 7. Alright, number 7. What if you have a cube root? Right, so the same thing here. What we have to do is that we have to find the highest power of x in the denominator. Is it x squared, or x to the power of 5? So of course, x to the power of 5 is the highest power. So divide every term with the x to the power of 4. So limit as x approaching a negative infinity should be divided with, right, everything should be divided by x to the power of 5. Plus 2x to the power of 3 over x to the power of 5. Minus x over x to the power of 5 over, right, 3x over x to the power of 5 minus 2x squared divided by x to the power of 5 minus 27x to the power of 5 divided by x to the power of 5. Right, please don't forget your cube root symbol. Right, this is cube root, be careful. Alright, so now you're gonna simplify this. Alright, so we'll have limit as x approaching a negative infinity of, alright, cube root. So 64 plus 2 over x squared minus 1 over x to the power of 4. The whole thing over 3 over x to the power of 4 minus 2 over x cubed minus 27. Alright, so we have this. Okay, so now we are going to substitute the value of f with negative infinity, so you don't have that limit anymore. So you get 64 plus 2 over infinity minus 1 over infinity, right? So you have 3 over infinity minus 2 over negative infinity minus 27, right? Please take note that part here I'm highlighting in green yellow color will lead to 0 because the every term is divided with negative infinity or an infinity. Alright, so this will be 64 plus 0 minus 0 over 0 plus 0 minus 27. Okay, so this will be simplified as cube root of 64 over 27. Please take note that cube root of 64 over 27 is actually 4 over 3. So your final answer is actually positive 4 over 3. I'm sorry, be careful, this is not positive 27, this is negative 27, this is 4 over negative 3. So this is simplified as negative 4 over 3. This is your final answer, be careful. Alright, don't make silly mistakes just like I did just now. Alright, number 8. What if you have limit, okay, we have the power of 3 as the power outside there, but never mind, you just look at your denominator here. In this case, this is the highest power of x. Alright, so in this case, we're going to divide every term with x to the power of 3. So this is what we have, limit as x approaching a positive infinity of 4, okay, the whole thing divided by, every term will be divided by x to the power of 3 plus 2x over x to the power of 3 minus 5 over x to the power of 3. The whole thing over 2x to the power of 3 over x to the power of 3 plus x squared divided by x to the power of 3. But don't forget this power of 3 there, alright? Outside the brackets. Now we're going to simplify this, alright? So limit as x approaching positive infinity will give you kind of 4 plus 2 over x squared minus 5 over x to the power of 3. The whole thing over 2 plus 1 over x. The whole thing to the power of 3. So now, what we have to do is that we have to substitute the value of x in positive infinity. In this case, we will have 4 plus 2 over infinity minus 5 over infinity. The whole thing over 2 plus 1 over infinity to the power of 3, right? So we will have, alright, so please note that this part will become 0 because each term is divided by positive infinity there. So we get 4 plus 0 minus 0 over 2 plus 0, the whole thing to the power of 3. So we'll have actually 4 over 2 to the power of 3. What is 4 over 2? 4 over 2 is actually 2 to the power of 3. So 2 to the power of 3 is calculated as 8. Alright, you can simplify your final answer as 8. So meaning to say that if you have this kind of function, so as approaching positive infinity, so the function will approach the value 8. Alright, and the last one here, alright, we're gonna have this limit as approaching negative infinity, but we have different power here. Alright, please take note that it has different power here. Okay, so what we have actually, alright, so firstly you try to highlight the highest power of x in the denominator. So this is x to the power of 3, but we have to the power of 2 here. Alright, we have power 2 here. So actually the highest power of x that occurs in the denominator is not x to the power of 3 but x to the power of 6. Why? Because we have x to the power of 3, we have a square outside that, so this actually x to the power of 3 multiplied by 2, so this is x to the power of 6. So we're going to divide each term with x to the power of 6. Alright, but be careful, alright, something like this. You must have the strategy of answering this question. All right. So firstly, I'm going to write that we are going to divide each numerator and denominator with the x to the power of 6. All right, 5x to the power of 3 over x to the power of 6. All right. So this is actually 7x to the power of 3 minus x squared to the power of 2 over x to the power of 6. All right. So in this case, Alright, x to the power of 6 can be written as x to the power of 2 but outside it to the power of 3, or it can be written as x to the power of 3, outside it is square. Alright, so what we are going to put inside this bracket here is actually divide each term with x to the power of 2, because we have to the power of 3 outside there. And for this term we have x to the power of 3 inside the bracket, divide each term with x to the power of 3 because we have to the power of 2 outside here, the same as this. Alright, okay, so now we're gonna have something like, alright, so limit as x approaching, limit as x approaching a negative infinity, right? So we have something like 2x squared divided by x to the power of 2 plus 5x divided by x to the power of 2. The whole thing is to the power of 3. Why we have this? Because if we multiply this, actually, right, x to the power of 3 with x to the power of 2 divided, multiply with 3, so we'll get x to the power of 6. So same goes to this, alright? So we can put inside the bracket that each term will be divided by x to the power of 2 at the numerator. So now, at the denominator, alright, what happens? Alright. At the denominator, we can have, right, we're gonna put inside in the bracket is actually x to the power of 3, so each term will be divided by x to the power of 3. So 7x to the power of 3, what happens? Alright, 7x to the power of 3 divided by x to the power of 3, alright, minus x to the power of 2, x to the power of 2 divided by x to the power of 3, right? The whole thing to the power of 2, right? So now we will have to simplify this, right? So this will be limit as x approaching negative infinity, right? So simplify that, so we'll get 2 plus 5 over x, the whole thing to the power of 3, over 7 minus 1 over x to the power of 2. So now we are substituting the value of x in negative infinity. So now you will have, alright, so 2 plus 5 over negative infinity, the whole thing to the power of 3, over 7 minus 1 over negative infinity, so to the power of 2. So we'll have, alright, so please note that this part and this part will become 0. Alright, so we'll have 2 plus 0, 7 plus 0 square. Okay, so we'll have actually 2 to the power of 3 over 7 square. This can be simplified as 8 over 49. So this is your final answer for this one. Alright,